This video is about materials and processes in wastewater treatment according to the safe and sustainable by design principles. Plants and animals need safe water. We need drinking water to live and for most of our everyday activities. Clean water is essential and should be accessible to all. However, an increasing percentage of the available water is polluted due to the increasing population and to bad human actions and decisions that do not consider always the environmental and societal impact. Therefore, we need to find safe and sustainable solutions to clean wastewater. Wastewater treatment can be done at different levels, depending on the selected type of reuse. Drinkable water, irrigation, or industrial use, for example. So we can simply separate the contaminants from the wastewater through absorption or filtration processes. However, this means that we will produce a waste that contains all the contaminants that were previously in wastewater and that need to be disposed as a waste. A better option, when possible, is to use a technology that abates the contaminants and leaves clean water without any further waste. Based on the wastewater type, we can also decide to focalize the wastewater treatment on one class of contaminants, for example, only bacteria or only organic compounds, only dispersed solid, although this depends on how the treated water is reused, of course. And it is always better to extend the treatment to all the existing contaminants if possible. The wastewater treatment can be physical, for example, sedimentation, or biological, so the removal of bacteria, or chemical, so filtration or advanced oxidation treatments. Finally, to address the wastewater issue, interdisciplinary and even transdisciplinary approaches are needed. And rarely it happens that the best solution is just a matter of science and technology. More often is the result of a complex interaction among researchers, companies, citizen organizations, policymakers, and investors. When we think to the best technology to be used, we follow the safe and sustainable by design principles, the SSbD principles. For example, we think at the past and study on the previous knowledge, learn from the errors made in the past and identify the most urgent needs. Therefore, the first step is to study the previous literature about the topic and identify possible improvement with respect to the actual technologies. Moreover, we consider any possible negative impact on the environment, society, and economy. For example, our technological solution could be very efficient in principle, but it might produce an excessive amount of waste that would contribute to the environmental pollution. It might also happen that we realize that our technology is in contrast with actions taken by citizens or policymakers. Our technology could be so expensive that we might not find any company that will buy and use it. And we also look for any benefit that our new technology could bring to the environment, society, and economy. For example, will our technology improve the life of citizens at local or maybe national or even international levels? This is the question that we ask ourselves. Finally, we think about any consequence of the technology on future generation, and at the same time we try to imagine what kind of benefits our technology might bring in the future. For example, we ask questions as what will happen after that the components of the wastewater plant are exhausted? Will they represent an issue for the future citizens, or can this technology be further implemented in the future to extend the applicability and address other important needs? Wastewater treatment technologies are based on the design of materials and processes. If materials and processes are designed according to the SSbD principles, then the technology is safe and sustainable. The synthesis of a material is performed starting from a precursor, that is the source of the element needed for the final material to be produced. The precursor should be available at low cost and, if possible, derived from waste, especially if the selected element is critical. Moreover, precursors should be not toxic. Produced materials should have high performance, high durability, multifunctionality, low toxicity, and should be able to be easily disposable or better usable after first use. Moreover, the application should bring benefit to the environment and society without impacting negatively on them. Another important feature is the possibility to extend their use to other applications. For example, if the wastewater plant is constructed, is created for the abatement of a specific class of contaminants, it would be good if it's possible, for example, to extend the class of contaminant in the future with the minor change to the plant or something similar. This could add a further value to the plant, of course, to the process. Finally, the synthesis process, like any process, should be efficient, high yield, easy, fast, energy saving, cost saving, scalable, safe, and should produce also a low content of waste. This is very important. It is better if the same synthesis could be applied to other materials, but these are features that are representative of any process, not only the synthesis of materials, but any transformation, chemical transformation, for example, the biomass transformation into biofuel or any other process that involves chemistry. So these are the main characteristics that should be taken into account when the design of sustainable processes is considered. In conclusion, wastewater treatment can improve the quality of our lives and of the future generation if it follows the safe and sustainable by design principle. The most important decisions and actions should be taken by scientists on design of materials and processes in close collaboration with the other wastewater actors. Thanks for watching this video and thanks for your kind attention.